Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important past paper question on electromagnetism from October-November 2021, paper 4, variant 2. In this question, we will discuss about right-hand grip rule. Then we will also talk about Fleming left-hand rule and how to use Fleming left-hand rule. Then we will talk about forces acting between two wires when current is flowing in the wires in the same direction. We will calculate force acting on one of the wire, and then we will compare the forces acting on two wires. So we will discuss some very important concepts about electromagnetism in today's lesson. So listen carefully and try to improve your understanding of electromagnetism. For question number 8, it is given to us two long straight parallel wires P and Q carry currents into the plane of the paper. As shown in figure 8.1, wire P carry current into the page. This cross is representing current is into the page. So simply we can write down cross represents into the page. This is very basic symbol. You need to be very clear. Cross means into the page. And if there is dot represents out of the page, out of the page, out of the plane of the page. Out of the page. So in wire Q, current is also into the page. Current in wire Q is 2I. Current in wire P is I. For part A1 on figure 8.1, so here is figure 8.1. We need to draw an arrow to show the direction of the magnetic field at wire Q due to current in wire P. Means we need to draw the magnetic field due to wire P at wire Q. So first of all, let's try to understand how we can find direction of magnetic field around wire P. So imagine that this is wire P. If we need to draw magnetic field, let's say at this point, we have to use right hand grip rule. So simply we have to use right hand grip rule. Right hand grip rule. By using right hand grip rule, we can find direction of magnetic field at this point. Around this wire, if we draw the magnetic field, this will form a circle. So the magnetic field around this one will be like this. Magnetic field nearby, this will be here. At this point we can find, so this is at one point we can find magnetic field. The next one magnetic field we can find at this point. And this one, if you use your right hand grip rule, in this case current is into the page. So direction of magnetic field is clockwise. So direction of magnetic field is clockwise. Now if we need to find magnetic field only at this point, so we need to draw the tangent at this point, and tangent will be pointing down. So the tangent is pointing down. So here tangent is pointing down. So direction of magnetic field at this point is down. So this is direction of magnetic field at this point. So simply we need to draw arrow pointing downwards at any point. For example, if I ask you what is direction of magnetic field at this point, so simply you have to draw arrow in this direction. If direction of magnetic field at this point, so simply you can draw this line and magnetic field is tangent to this. This angle is 90. So this is how you can draw magnetic field at any given point around any wire. For the second part on figure 8.1, we need to draw another arrow to show direction of the force acting on wire Q due to current in wire P. Label this arrow F. So first of all, let's try to understand if current flow in two wires in the same direction. So I will explain you the main concept first of all. Let's say we have these two wires and current is flowing in these two wires in the same direction. So these two wires, they will attract each other. So they will attract. So simply we can say they will attract. So the force, let's say this is wire P and this is wire Q. So Q will be attracted by P and the P will be attracted by Q. So using this knowledge, simply we can say the force on wire Q, this will be to the left. So this is direction of force. So this is how you can answer. Later we will discuss with the help of Fleming left-hand rule as well. The second thing you need to understand, let's say we have these two wires. Let's say this is wire P and this is wire Q. And if current flow in opposite directions, then these two wires, they will repel each other. So they will repel. Means the force on these wires will be away from Q and the force on the Q will be away from P. They will repel each other. So this is simply how we can answer. Now let's try to understand how we can answer this question using Fleming left-hand rule. If we need to find the force on Q due to P, force on Q due to P, we have to use BIS. So B is the magnetic field due to P, I is the current in Q, and L is the length of Q. So B is the external magnetic field. So simply we can say B is always, in this formula, B is external magnetic field. I is the current in the wire and L is length of the wire. So in this case, if you look at wire Q, magnetic field due to wire P is downwards and current in wire Q is into the page. Now we have to use Fleming left-hand rule. So first thing we need to understand, thumb represent direction of force. Thumb represent direction of force and index finger means this finger. So index finger, direction of magnetic field. So we will say direction of magnetic field represent direction of B means direction of magnetic field, and middle finger, direction of current. So middle finger means this finger represents direction of current means conventional current. Direction of conventional current. So this is what we need to understand. Now for this question, we have direction of magnetic field. Direction of magnetic field, index finger is down. So direction of magnetic field is downwards and current is into the page. Current is into the page. So if we rearrange our fingers, index finger down and current into the page, so direction of force will be to the left. So this one is the middle finger. So this is current, this is B, and this represents direction of force. Now let me show you this one with the diagram, but you can do this one by yourself. So this is how you can use. Let me make some space. So here you can see in this case, this is current I, this is into the page, and this is B, this is pointing downwards, and this one is direction of force. So this is how you can find direction of force using Fleming left-hand rule. For part B1, we need to state with a reason how the magnitude of the force acting on wire P compare with the magnitude of the force acting on wire Q. First of all, let's try to find out force on Q by P. Simply you can say force on Q due to P. Force is equal to B external. So in this case, external field is due to wire P. So we can say this is BP. I is current in wire Q and L is length of wire Q. Now we need to understand how we can find out magnetic field at this point due to wire P. For any wire, if current is I in the wire and the wire is very long, we can find out magnetic field at any point. Let's say we need to find magnetic field at this point for this wire. So magnetic field simply will be equal to mu naught I divided by 2 pi times the distance between this point and the wire. So in this case, that is equal to R. Now again assume that if the distance between these two wires, let's say, is equal to R. So the magnetic field due to P at Q, this will be equal to mu naught I divided by the distance between two wires. So this is the magnetic field at Q due to P. So simply we can plug in value of this. We can say this is mu naught IP, current in wire P, divided by 2 pi R, and this is multiplied with IQ times LQ. Now we can repeat the same process for wire P, means the force on P by Q. We can do the same process. So in this case, this will be be magnetic field due to Q, and this will be the current due to P, and this is length of wire P in the magnetic field. And in this case, we have two long wires. So LP, this is equal to LQ. We can simply say this one is equal to L. Now, if we write down the formula, in this case, we will say this is mu naught IQ over 2 pi r times IP times LP. If LP is equal to LQ, we can say that this is mu naught IP IQ times L divided by 2 pi r. This one also we can rearrange. We can say this is mu naught IP IQ L divided by 2 pi r. Now, if you look at these two formulae, if you compare these two formulae, you will see they are the same. So these two formulae are the same. So simply we can say force on wire P and force on wire Q is the same. So first thing we can say same, or you can say equal. So the force on P due to Q and force on Q due to P, they are the same, or you can say equal. Forces are equal in magnitude. The second, you need to give a reason. So simply in this case we can say force is proportional to IP and IQ. So it's proportional to product of P and Q. So that's the reason forces are same. You can also say that by Newton's third law. You can also state this one. You can say by Newton's third law. Any 2 points you can write down. First one, you have to state same or equal. Then you can say force is proportional to product of IP and IQ. So the magnitude of force is the same. Or you can say forces are same by Newton's third law. That's all what we have to write down. So this question has 2 marks. If you have written same or equal, you will get 1 mark. Then the second mark you will get if you have written F is proportional to product of IP and IQ. Or if you have written by Newton's third law, you will get 2 marks. Now for the next question, for the second part, state how direction of the force on wire P compares with direction of force on wire Q. We have already discussed this point. Forces on these two wires are in opposite directions. So force on Q is to the left. So the force on P, this will be to the right. So simply you can say forces are in opposite direction. So simply you need to write down forces are in opposite direction. So you can say in opposite direction. That's all what we have to write down for this question. I hope this question is clear to you. If you have any questions about this, just leave your question in comments section. If you want to write down your answer in a proper way, this is how you can write down your answer.